Hello everyone, I think you are doing well. Okay, today let's start with practical geography. Today we'll discuss about the bar graph and again line graph. Again there will be different types of line graph and again the pie diagram, right? Pie diagram shows different types of data. So what is bar graph, right? Bar graph means graph. Graph we know that already. We represent what? We represent two things in a graph. That is called graph, right? So what is bar graph? Just we'll see the definition, right? The graph in which the trend of population, trend, you have to remember, you have to see this word trend. Trend of population or production of an area for a considerably long period of time. Long period means not as the 30 years or 40 years, just for a long period, or 2 months, 3 months, right? Or 1 year. We can consider 1 year also. 1 year. So long period of time of is represented through rectangular bars. Do you know the meaning of rectangular bars? Because bars are already rectangular like this, right? Rectangular bars is known as the bar graph. Okay, you have to remember. So I am repeating these things. What is bar graph? The graph in which the trend of population or production of an area for a considerably long period of time is represented through rectangular bars is known as the bar graph. Okay, so I'll show you how this rectangular bar is there. So you know already rectangular bar because you have got these things in your lower classes because you are coming from this class 6, 7, right? So rectangular means actually we know this is x-axis, this is the y-axis. Okay, suppose here in this line, that means in the y-axis this is 0. So this is x-axis is always horizontal, y-axis is always vertical, right? So in the y-axis we are showing, suppose year. I am writing here year, okay? And here we are showing the production because already we have discussed this production or population, right? So in this direction we are showing the production. So rectangular means what? Suppose this diagram will come like this, okay? So this is the rectangular, right? So this is called the bar graph, right? Why it is called bar graph? Bar means this rectangular portion is called a bar. But why it is called graph? Because we are representing in the graph. Graph means when we are taking this x-axis or y-axis to combine, to show the combination or to show the any differentiation or any similarities between the things, that is called the graph. Okay, right? So this is the bar graph. Okay, this is the example one. Population growth in Assam 1951 to 2001. That means this table is showing what? This population, one side population year, that is census year. Another side, that is population in million. In million means in million. Okay, so from which year to which year? 1951 to 2001. That means after independence. Okay, so in 1951 we will see 1951 8.0 million, 1961 10.8 million, 1971 14.6 million, 1981 18.0 million, 1991 22.4 million, and 2001 26.6. So these data, so we will represent through bar diagram, right? Now we'll represent or we'll paste in the bar diagram through the rectangular diagram. Okay, this is the bar diagram. So this is the outcome of the graph. So whatever we have seen, that graph is 8 point that million or 8 point something million, right? So that means what? So here actually it is growing in 1951. Here in this is the y-axis, this is the x-axis, right? So this is x-axis, we can write here, this is the y-axis. That means what? Through y-axis we are representing the population in million. So we are taking 0, 5 million, 10 million, 15, 20, 25, 30 million up to like that. Because before taking this 30 million, actually we have to take these things as an average, right? So this is 1996. And this year, in this x-axis it is showing the year 1951, 1961. This is 51, 71, 81, 91, 2001. That means what? One decade, first decade, second decade, third decade, like this. So here what is the value? 8.0 is the value, right, in 1951. Then 10.8 million here. Okay, just this is the only simple informal diagram, not actually according to the scale, just I am showing to you. again in 14.6, right? Again 18.0, again in 1991 22.4, again in 2006 26.6. That means what? So this is a trend, right? This is a trend. Trend means what? So we have discussed already in the definition what is the bar diagram. The trend of population growth or any production growth. That means what? So yearly population is growing, not decreasing. If it will decrease also, then also it will be called a trend. But step by step it is increasing, right? So in 1951 8.0 was 0 million was there. In 1961 10.8, 1416, gradually it is increasing, right? Up to 26.6 in 2001. That means what? Trend. Trend means this is the step by step gradually increasing things are called a trend. Okay. So through this diagram, this rectangular diagram, this is called the bar diagram. So we can show or we can combine or we can compare this year with the population increase. So when we show two things with combined graphically, that is called the bar diagram. But rectangle should be there. So if we will show the according to the through the line diagram, then it will come to the line graph. Okay. So in next, I'm showing you line graph, right? We will see the another example, that is example 2. Okay. Here we will see the food crop production in Northeast India 2001 to 2002. But here only we will see only 2 years, right? So Northeast India, we know that 7 states are there, including Sikkim, 8 states are there. So state Arunachal Pradesh 2.2, that is volume of production in lakh ton. L dot ton means lakh ton, right? So state volume of production Arunachal Pradesh 2.2, Assam 4.2, Meghalaya 4.0, Mizoram 1.3, and Tripura 6.3. Now this data, this table data of this food crop production in Northeast India will represent in the bar diagram, right? And this is the diagram, bar graph. So here in this y-axis, I have already told you, in y-axis we show what? We show production in ton or population in ton like this. So 10, 20, 30, 40, we are taking this because 40 is the highest, that's why we are taking 40. From 10, 20, 30, 40, equally we have divided production in million ton. So this first bar is representing Arunachal Pradesh. That means Arunachal Pradesh generally food production is something low. That means very low, very few. Then Assam. So Assam is the plain area. We know geographically Assam is the plain area, and it has vast difference with the all other hilly regions because plain regions generally get the advantage because their transportation and network communication is good. Again, population density is good, agricultural fields are good, and the supply of the communities are good because we know the God is called the Gateway of Northeast, right? So being a population of the Assam, so we know everything regarding Assam, what is the advantage, what is the disadvantage. So food crop of Assam is actually something high with comparing to other these states, right? So this is reaching up to 35. And again, next is the Meghalaya. Meghalaya means Meghalaya something, it is near to Assam and it is near to Guwahati. That's why it is what? After Assam, something, food crops is something high than this Arunachal Pradesh in Meghalaya. Again, Manipur, MNP is representing Manipur, ML for Meghalaya, AS for Assam, AP for Arunachal Pradesh, right? Again, in Tripura is something, political condition is good, something, some plain regions also we can get. That's why food production is also, but network communication is something difficult, right? So, but then also with comparing to Arunachal Pradesh and the Meghalaya and the Manipur, so Tripura is something high in the food crop production. That means what? When we represent this bar diagram, when we draw this bar graph to represent the different commodities in the different production, right? Comparing, but so it shows what this outcome gives. What from this diagram we can come to know which state is leading, which state is actually getting the more facilities of the production, which state has producing the more goods, and which is the least in the number. So this diagram actually represent the overall production or overall one of this image of this productive or this particular area, right? Okay, let's move to the line graph. So line graph we learned. Line graph is something similar to the bar graph, but just only in the line graph we draw the line, in the bar graph we draw the rectangle, right? So what is line graph? We'll see the graph in which the trend of population, again trend of population is coming, production etc. of an area for a considerably long period of time, again time is given here, long period of time, is shown with the help of the line. It is called the line graph. Okay, So what happens? The graph in which the trend of population, production, etc. are considerably long period of time, right? Again, we will show the this combination or the what is the relationship between this production and the time, right? Line, it is called the line graph. Okay, let's see the diagram, right? So line graph data is given here, right? Year 1990, this year rice production Assam 1990 to 98, right? So year is given here, 1990 to 91, 32.7, that is production in lakh ton. Again 1991 to 92, 32.0, 1990 to 93, 33.0, 1993 to 94, 33.6, 1994 to 95, 33.1, right? 1995 to 96, 33.9, right? 1996 to 97, 33.3, 1997 to 98, 33.8. So it is given in lakh ton. Now we'll represent these things. This year is given. So these things according to the line graph. So we know the line graph is like this. This is y-axis. This is x-axis. So generally bar diagram is we represent through the rectangle, but line graph is we represent through like this. So through this diagram we will show, we will represent this data in the next diagram, right? Now we have reached to the graph. So this is the line graph. Earlier we have represented. We used to represent through the rectangular portion, but now we can represent through the rectangular also. Means rectangular this diagram also. But line graph is something in some cases to show some datas. Actually, line graph is favorable, right? So here production in ton. In the y-axis again we are taking this x-axis. 30, 31, 32, 33, 34 according to the table we have shown in the figure. So this line graph is coming through this 1990 to 91, right? 92, 93, 94, 95, 96, 97, 98. So like this what happened? Production in 1990 to 91, how much production was there? In 92, how much production was there? In 93, something down production is there. 94, something up comparing to the 93. Again 95, something down is there. Again 96, something up, because in 96, 97, because of some problems, because of some this cause, because we know some causes behind this. So because of some causes what happened? Line graph is showing the upward direction. That means the trend of production is something high. This production is increasing. Again 97, something it is, but likely to be increasing, not down. So that means what? From 1990 to 98, so within this stipulated time, so production is actually increasing, right? So this is the line graph. Next is the pie graph. Pie graph, that means what? The graph in which pie graph or pie diagram is same, right? So the graph in which the part values of a geographical element. Geographical element means those related to the geographical things. Element of an area is shown proportionately. Proportionately means step one by one portion, another portion. So we divided into different portions, different parts proportionately. It is called a pie graph or wheel graph. The land use, population, composition, etc. are shown with the help of the such pie graph. So again, I am repeating again. Pie graph, that is the graph in which the part values of a geographical element of an area is shown proportionately. That means into different parts. It is called a pie graph, right? Or wheel graph. Wheel graph means pie. We know that is we draw the 360-degree circle. After that we divide it into different parts or several parts. Then again percentage wise or angle wise we calculate it. Then again we just represent in the graph, right? The land use, population, composition, etc. are shown with the help of the such of pie graph, right? So for example, just I am drawing the pie diagram here. So like this what happened? First we draw the 360-degree circle, right? Again what happens? So we divide into several parts, right? We divide into several parts. That means what? So this portion another, this 30% is, again this portion another, this portion 50% is, this portion 40% is, right? This portion 60% is. So like this what happened? Like this we divide into several parts, several category. Suppose here this is land use is there, right? Land use. Again here suppose barren land is there, right? So like this what happened? So we divide into this 360-degree circle, divide into several parts. First we have to calculate the degree with percentage, right? So this 30% will come up with how many degree? Whether it is 30 degree or 50 degree or 60 degree like that. So after it what happens? We represent it. That means what? From this whole circle, whole diagram, we can come to know that, so this portion is belongs to barren land, this portion is belong to land use, this portion is belong to wasteland, so like this, right? So that is the pie diagram. So okay, we'll take one example. Again, we will represent the data, right? So total land area is this is the for example, we are taking the chart. So we'll calculate the land use of Assam 1997 to 1998, right? So here in the left side, land use 1000 hectare. So this forest area will calculate in the 1000 hectare. That means the total area is 1000 hectare. Land area 1930. That means 193 this 1000 hectare, right? Again, agricultural land 2751 1000 hectare. Non-agricultural land 2892 1000 hectare. Fallow land 277 1000 hectare. So total is 7850. Also in the pie diagram, this value is most important, right? This value is most important, and this value we consider as the 100%. Okay, this value we consider as what? 100%, right? That means the total. Then again, what happened? So we are calculating, suppose this forest land into degree. So how we'll calculate? So one formula is there, right? So formula is what? Given land area divided by total land. Given land area divided by total land. So but we have to convert to degree. Okay. So what is the total degree of one circle? 360 degrees. So we have to calculate it with 360, right? So that means what? Total is 93,000. Okay, we have written here 1000. This is the 100% total, 7850,000 into 360. So if we'll calculate, we will get the 88. That means 88 degrees that is the forest is the 88 degree, right? So like this, what happened? We'll calculate all these remainings, this agricultural land, another land, again this snow covered area land. So this all this remaining land we'll calculate like this, and this is the outcome, right? Land use type. So after calculation, after calculating all this angle or applying to that formula, that total given area divided by total land area with the 360. So this 360 we consider as what? 100%. So that means what? So we have got this forest land 88 degree, this agricultural land 126, non-agricultural land 133, fallow land 13 degree. So with calculating this, we have got the 360 degree total. That means 360 degree, one circle is the 360 degree, right? One circle is the 360 degree. Now this 360 degree circle we can divide into 13, 133, 126, 88, like this. We can divide. Okay. When we'll divide, when we'll apply this diagram, then our result will come. And this is the outcome. That is the land use type. Forest, that is the 88% we have got. So we divide into this 88 degree. Agricultural land, that is the 126 degree we have put here. Non-agricultural land 133 degree we have put here. Fallow land, that is 13 degree we have put here. That is the, and the total 360 degree we have got, right? So with this diagram, it is very easy to show the land use pattern or whatever the data actually related with the geographical phenomena, right? So I think students, you have understood everything. If you have any query, you just give in the feedback session. So this is the end of the chapter up to here. Thank you. All the best.